Okay, as mentioned, we're just going to do some of the problems from our final. Right, so starting off here with question number 1. You roll 2 4-sided dice. Create a table to list the outcomes for the product of the 2 dice. All right, so of course the main thing that we're being told, create a table. Now the table is just another word for a chart. And when we were doing those, we had a really large box for option 1, 2, 3, 4. And basically over here, this is what we can get on the first die. Well, we could get a 1, which gives it a whole row. We could get a 2, which gets its own row. We can get the 3 or the 4. So those are the 4 different options because it's a 4-sided die. Along the top, we'll list out the options for the second one, the second of the 2 dice. And just like before, we could get a 1, a 2, a 3, or a 4. And so each one of those gets its own column, and we've got the basic outline for the table. At this stage, we're going to actually crunch some numbers and start filling in the table for the different outcomes, specifically for the product. Well, what does product mean? Since that means multiply, it tells us we have to multiply each pair of numbers. The most common mistake people made was to do the sum of dice. And granted, we did a lot with adding the 2 dice together, but this one doesn't tell us to add, it tells us to multiply, so we have to multiply 1 times 1, 1 times 2, 1 times 3, 1 times 4. 2 times 1, 2 times 2, 2 times 3, 2 times 4. 3 times 1, 3 times 2, 3 times 3, 3 times 4. 4 times 1, 4 times 2, 4 times 3, 4 times 4. And we have now created our table. In order to list out the outcomes, which is just another way of saying write out the sample space, we'll just simply look at our chart, look at our table, and say, what is it that we got? What numbers came out? Well, we encountered 1, 2, 3, 4. What else? 6, 8, 9, 12, and 16. Of course, you'll notice we did not write down any repeats. When you're writing up a sample space or a list of outcomes, you don't need to write down repeated values. And here we go. This one's finished. We've created a list of the outcomes, all the possible outcomes when you multiply 2 dice, as long as they are 4-sided dice. All right, continuing to the second question. You are dealt 2 cards from a standard deck of 52 cards. How many different outcomes are possible? Observation you have to make here. We're picking items from a group. Whenever we pick items from a group, it should make us think about combinations or permutations, because that's exactly what combinations and permutations are. They're picked. It's just a formula that counts out how many ways are there to pick from a group. And we remember the difference with a permutation. The order is important. And with combinations, the order is not important. So if you're looking at this situation and saying you're playing blackjack, you're playing poker, you're playing some kind of card game, does it matter what order you get your cards? Okay, since you're saying no, that tells us we're using a combination. The first number in combinations, which we remember is always the bigger of the two numbers, is how many are there available to pick from? What is the size of the group? And this has 52 cards in a standard deck. The second number is how many of them you're going to pick, or how many of them you're going to choose. Yeah, you're being dealt 2 cards, so this is precisely what we needed. 52, choose 2. And this is what we will now put into our calculator. Do you remember where it's located? Using our TI-84, we know permutations and combinations are located under the math button right here. And in the math feature, we'll scroll over to the probability section. And now option number 3 gives us combinations. So we'll type in 52, choose 5, 5 was 2. 52, choose 2, and we get our answer of 1,326 ways. And this one's finished. In question 3, how many ways can a first, second, and third place winner finish a race if there are 12 runners? Do you notice that this is once again a permutation versus combination? We're picking winners from a group. Does the order matter for this one? Absolutely it does. Ask any racer, does it matter who finishes first, second, and third in the race? You bet they're going to say yes. So this gives us a permutation problem. How many are available? There are 12 runners available. How many need to finish the race? We're looking for the top 3 places, so we'll put this into our calculator. 12 permute 3, located in the exact same place, back in the math menu, over in the probability section. Option 2 gives us permutations. So we have 12 permute, or 12 pick 3, giving us 1,320 ways. It's kind of incredible that it's so close to the last one, but just dumb luck, I guess. Progressing to question number 4. Admittedly, question number 4 is a bit longer. A high school baseball player has a batting average of 400, which means that he averages 2 hits for every 5 times he comes to the plate. Create a probability model for the number of hits the player could have if he comes to the plate exactly 3 times in a single game. So 0, 1, 2, or 3 hits. All right, let's make sure we understand what we're being asked. We are specifically told, create a probability model. And we know a probability model will list all the different outcomes. So basically you just list your sample space like we did in option number 1, or in question number 1. Well, we're actually told it, so we didn't have to figure that out. You can get 0 hits, you can get 1 hit, or 2 hits, or 3 hits. That's our sample space. And a probability model lists the probability for each one of those different outcomes. So we need to determine what is the probability that this player gets 0 hits, what is the probability that they get 1 hit, or 2 hits, or 3 hits. In order to determine those probabilities, we needed to create a tree diagram. And I'll scroll down and I'll have to scroll back up. But when we create our tree diagram, we're told that this player comes to bat 3 times during the game. So we will have first at bat, second at bat, third at bat. In the first at bat, there are 2 different options. He could get a hit or not. And likewise for the second at bat, there are once again 2 options. Getting a hit or not. And we'll continue this down to the third level as well. At each juncture, there are only 2 possibilities. Getting a hit or not getting a hit. At this point, we need to start writing down the probabilities. What is the probability that this player gets a hit? We were told, and scrolling back up to the top, that they're a 400 hitter. So that's the probability that this person gets a hit, 0.4. Keep in mind, if it's a 0.4 probability of successfully getting a hit, what is the probability of not getting a hit? We could subtract that probability off from 1, giving us 0.6. The probability of not getting a hit is 0.6, or 60%. That is information we will need to place all over our chart. Each time the guy gets a hit, there's a 40% chance of getting it because of the independence of at-bats. Each time he does not get a hit, it is a 60% chance. So each path along the N for not hit is 0.6. And we have now completed our tree diagram. In order to calculate the probability model, we can say the probability of getting, we're just going to follow the paths and see how many hits he gets. Hit, hit, hit. How many hits were there? Okay, so 3 hits has a probability of 0.4 multiplied by 0.4 multiplied by 0.4, taking each of the 3 paths. So using our calculator, just to speed up the number crunching, 0.4 times 0.4 times 0.4 gives us an overall probability of 0.064. Okay, so we'll write that down. All right, following another path now. And, okay, what about this path? Hit, followed by hit, followed by no hit. How many hits were there? Okay. And what is the probability there? 0.4 times 0.4 times 0.6. That gives us 0.096. Now, I would like to note, this is not the only path to getting 2 hits. There is also this path of hit, no hit, hit. That's a second path that leads to getting 2 hits. And then over here we have no hit, followed by hit, followed by hit. That is a third path that leads to getting 2 hits. Well, every path has this probability of 0.096. And since there are 3 paths, we have to multiply that by 3, which comes up and tells us that the probability of getting 2 hits is 0.288. Well, I'm going to take these 2 values that we've calculated already, and I'm going to take them up and put them into our chart. Since we've already calculated them, the probability of getting 3 hits, or 2 hits, was 0.288. The probability of getting 3 hits was 0.064. And now we also have to calculate 1 hit and 0 hits. The work for these is the same as what we did for 2 hits and 3 hits. So I'm going to speed up and go through them much more quickly. Looking at the path for getting 1 hit, hit, no, no. Well, that's 0.4 times 0.6 times 0.6. Multiplying those out gives us 1 hit with a probability of 0.144 for this one path. Now we would also note that there is the path of no hit, hit, no hit, which is a second path. And then there's also no, no, hit for a third path. So just like before, we'd multiply it by 3. So we'll scroll up and write that one down. And then we'll take our last path. No hit, no hit, no hit. So 0 hits is 0.6 times 0.6 times 0.6, which is 0.216. And that's the only path that leads there, so we wind up with 0.216. And thus, all of this tree diagram is the work which leads us to create this probability model. Definitely a lot of work. But that's why it's worth so many points, because it is a lot of work. Now, before we move on, we still have to answer the other question. What is the probability that they get exactly 2 hits? Well, the probability of getting exactly 2 hits, we can just read it directly from our probability model. We've already done the work. That's 0.288. Or if you prefer, we can say it's 28.8%. And we're finished. Yes. Making the important observation that when we take these 4 probabilities, these 4 probabilities must add up to 1. If you choose to write them as percentages instead of decimals, they must add up to 100%. Which is kind of nice, because if you wanted to, the last one we did was this 0.216. We could have just subtracted the other 3 off and got it that way. There's more than one correct way to get parts of these. This is just one valid method. All right, question 5. This table gives a breakdown of ages and genders. The first thing you will always do is fill in the table. So just go through and add them all up. Adding up each of the columns, we get 16, 17, 29, 18. Adding up each of the rows, 7 plus 9 is 16, plus 7 is 28, plus 10 is 38. 9 plus 8 is 17, 17 plus 17 is 34, 34 plus 8 is 42, which gives us a total of 80. Always start by adding up those. All right, now we will look at the probability that a randomly selected teacher is female. Well, we remember probability is number of successes over total. So how many successes are there? How many females are there? We've got 42 of them. Out of 80? Absolutely. So we would be able to write this up then, that this is 42 out of 80. And of course, if we wanted to simplify the fraction, we can. If we want to divide it out to write it as a decimal, we can. If we want to turn it into a percentage, we can. I choose to leave it as this fraction, 42 out of 80. Moving on to question B. Question B asks us, what is the probability that they're 49 years old or younger? Well, where do you get the group of people who are 49 or younger? Well, one thing to be careful about, this isn't just people in the 40 to 49 range, because if somebody is 32, if you're looking at 42, or I'm sorry, if you look at 32, 32 is still younger than 49. So people in their 20s count, people in their 30s count, people in their 40s count. That's each one of them. All three of these in the green are successes. So we'll have to add all three of those together. 16 plus 17 plus 29. That adds up to equal 62. So this has 62 successes out of 80. This is not the only way to get it. There are formulas we can do. There are other ways we could use the chart. There is more than one correct way to arrive at this probability. This is only one correct way. We'll transition now to question 3. And leave that one there and come here. We need either a female or at most 29. You need to be careful about the presence of the word or. A common error students will make here is to think and, female and 29. So some students will say, here is my group of females and younger than 20 and in their 20s. And so it's common for some students to say the number of successes is 9, but that's not the case. Female or under 29, or at most 29, that gives us any female is considered a success. Which we'll note is the same thing as just taking that block of 42. Or we could have people who are in their 29, or who are in their 20s, and that would include these men. Each of these in the teal are successes. So add them all up. How many total successes are there? We have 49 of them, so we'll take 49 successes out of the 80 teachers. And lastly, we'll move on to question D. What is the probability that they are a male given that they are less than 50? Well, This word given is really, really important to us because it tells us we are not looking at the group of all teachers. We're not looking at this group of 80. We're looking only at the group of teachers who are less than 50. So in this instance, we are looking at this combined group. Like we saw in question B, if we want the group of people who are 49 or younger, same way of saying the group of people who are less than 50, we're looking only at this group. So it's not just one column we're looking at, or not just one row, but basically we're looking at it and saying, get rid of all this stuff, and now we're working only with this table. Well, as we saw earlier, there are 62 people then in this table. That was our work from question B. So, what is the probability that they are male? Well, the males are here. There are 28 of them. Out of what sized group? Out of 62. Whenever you encounter this word given, it's telling us we're not looking at the entire group of everyone. We're looking only at a restricted, smaller subgroup. So our denominator is going to be smaller based on the size of that subgroup. Many times that will be only a single column. It might be only a single row. But as this example shows, it doesn't have to be one column or one row. It's just a smaller group, and you have to figure out how big that group is. And now we will go to question number 6. A woman who is 35 years old purchases a term life insurance policy for an annual premium of $450. Based upon U.S. government statistics, the probability that the woman will survive the year is 0.999057. Find the expected profit for the insurance company for this particular policy if it pays $500,000 upon the woman's death. All right, so there are several ways that we could do this thing. There are many ways of doing it. Mostly they pay attention. Mostly it regards us being careful with negatives. Every single instance, though, will rely on a probability model. Okay? Well, what are the two options available to this woman? She's either going to live or she's going to die. If she lives, how much money does she get? No. She gets nothing. If she lives, she gets any money, or rather her family is not paid any money. But if she dies, the family will be paid $500,000. Those are the payouts for the insurance company. Now in this instance, we have to say, what is the probability that she will live throughout the entire year? We're told that. 0.99957. Now we also have to calculate what is the probability that she will die. We're not told that directly. But like we did with the baseball player, how we can subtract off the probability to get the probability of its complement, we will do the same thing here. If we take 1 minus the probability, we will get the probability of everything else. And in this instance, that's 0, 0, 0, 9, 4, 3. And we have now successfully created a probability model. Progressing from here, we know that to get the expected payout for the woman, we would have to multiply and add each stage. So 0 multiplied by a probability, 0. 500,000 multiplied by its probability, that will equal $471.15. Adding up those options, we will get $471.15. On average, the insurance company would expect to have to pay this person $471.15. But that's not profit. We would have to also consider the fact that they are paid the premium. We have not yet used the annual insurance premium of $450. Well, whether she lives or dies, the insurance company gets that money. So we will subtract that amount off from what they would have to pay, which gives us $21.15. Now, you will notice that up to this point, I have avoided a lot of the negatives, because in the end, we will focus on just a single negative right now. Did the insurance company make or lose money here? They lost money, because you have to pay out $450 and you only get in, if you have to pay out $470, but you only bring in $450, well, the simplest accounting of all tells us that you have lost $21.15 from the perspective of the insurance agency. Which, by the way, insurance companies never operate this way. They would go out of business. For this particular insurance policy, and by the way, when you start talking about your car insurance, they do the exact same thing that we are doing. They do some statistics to calculate what is the probability that you, 17-year-old male, are going to get into a car accident. And then they calculate, based on the value of your car, how much money are they going to have to pay. So they do this exact same problem and look at it and say, we expect that for you, driver in North Dakota, 17-year-old male, we expect to have to pay $18,000 or $412 per year. Well, if they have to pay $412 per year on what they expect, you bet they're not going to give you $200 insurance. They're going to say $500, $600, $700. But they're going to make certain that they make money off you. Health insurance, by the way, works the same way. Every type of insurance works this way. Okay, question 7. Identify the sampling method used. Well, before we go on to this part, we're going to have to go through and put down some notes. So I'm not even going to look at the question right now, and instead just start looking at notes. Simple random. In a simple random sample, you have one huge list, and then you just pick people out of there bingo style. Second one, stratified random. People get split up into groups, and then you take a sample from each of the groups. Every single group will get picked. It's just not everybody in each group. It's a couple people from every group. For systematic random, you will randomly pick the first person, but then you follow a predetermined rule to pick the second person, third person, fourth person, and so on. But it follows a rule. For multi-stage random, you would have a simple random sample, and then inside that, you pick another one, and then another one. What you wind up with are picking groups inside of groups inside of groups. For example, randomly pick a state. California got chosen. Randomly pick a county. Los Angeles County got chosen. Randomly pick a school. Public School 118 got chosen. Randomly pick a teacher. Ms. Feinbaum got picked. Okay, now we're going to randomly pick 10 kids from Ms. Feinbaum's class. There are levels of choosing within choosing within choosing. That's what makes it multi-stage. Random cluster is easy to get confused with stratified because they both split people into groups. But there's a big difference between them. Instead of taking a little bit from every single group, you'll pick one group and do everybody. Or maybe you'll pick two groups out of everybody. But if you split the whole school up into 20 groups, a stratified random, you'll take a little bit from each of the 20 groups. In a cluster, you'll pick maybe 3 groups and do everybody in each of those 3 groups. Each of those ones are considered good methods. They're okay to use. We should avoid voluntary response. In a voluntary response, well, it's right there in the name. People have to volunteer. They have to say, yes, pick me. And lastly, for a convenience sample, fairly straightforward, just do what's easy. If it's easy for you to do, if it's convenient for you, that's what makes it convenience. All right, so with these bit of notes, we are going to answer this question. What type of sampling method is being used? A researcher randomly selects and interviews 40 male and 40 female teachers from a university with 122 female and 135 male. What type is it? This is stratified because we have a group of male teachers, we have a group of female teachers, so we're split up into groups. That instantly tells us stratified or cluster. But when they did their survey, they did not do a census of all males, they did a sample. They did not do a census of all females, they did a sample. Because they have sampled, that makes this a stratified random sample. And now here is our final question. Suppose after carrying out a survey of 350 women from State U, you found that 47 of the women said they did not feel safe walking on campus after dark. Identify each of the following. The population is the group of all people. It's everybody. So it's not the 350 because it's not only 350 women in the entire school. It's all the women at State University. Related to that, though, that group of 350 women that we're asking, that's the sample. The 350 women who are surveyed is our sample, so we've already got that for question C. Now, we know that right now our focus on confidence intervals is at an introductory level. And because it's an introductory level, the only type of parameter we're interested in are percentages. Later in the year, we'll come back and do confidence intervals for other things besides percentages, but right now, we are looking only at the percentage, and it's percentage of the population. Percentage of the women feel unsafe walking on campus after dark. For D is the actual statistic. It's the number crunching component that we will do. We actually have to calculate a percentage then. And so our percentage is 47 out of 350. Percentages are the same thing, or rather percentages are the same thing as probabilities. Success over total. And in this survey, the success was the 47 women who said they felt unsafe out of the total number of 350 surveyed. Success over total. And so we can divide this out, 47 divided by 350, and we'll turn that into a percentage. So 0.1342, 13.42%. And we now have our statistic. Margin of error. And once again, we know that this shortcut we're taking advantage of is not perfect. It's a shortcut specifically designed for 95% when it's based on percentages. And the margin of error is 1 over the square root of the sample size. Make certain you don't make the mistake of using 47, because it's not 47 for the sample size, it's the denominator from our statistic. It's how many people did you actually go talk to, how many people got surveyed. So this is 1 divided by the square root of 350. Using our calculators, what would we get? 0.0534, which is 5.34%. Please remember that margin of error is the plus or minus. We will wind up adding or subtracting this margin of error in this next part. Part F says to calculate the 95% confidence interval. All right, so we have to take this 13.42% and subtract 5.34. What's 13.42 subtract 5.34? On the low end, that's 8.08%. And we need to do the high end. Instead of subtracting 13.42 plus 5.34, adding those together, we have 18.76%. And this is our confidence interval. The last thing we need is the confidence statement. Basic template for it And I'm going to pause the video. You can pause it as well. Here is our basic outline. If you write up a confidence statement, we are 95% confident the parameter in the population is somewhere between confidence interval values. So we'll just basically take our answers that we had above and we're putting them together in sentence format. So we are 95% confident. Well, let's go back. What's the parameter? The percentage of women who feel unsafe walking on campus after dark on State U campus, because that was our population, the women at State University campus, is between, and now we'll just grab our confidence interval values, 8.08% and 18.76%. And there we are now finished.